Hi, Jim Sinesco for AFC International Institute of Technology, and today I'm actually doing some sampling, but unlike doing an inside laboratory sampling with the AccuSense, I have actually put the instrument outside. We're going to do some outside sampling. I've had requests from folks to say, hey, how about it's good to the lab, but how about putting it out in the field? So we're going to go outside and take a look at that. But right now, I did the last sample we did. I did administer some acetone to it outdoors. We got about 390 part per million, and I'll show you the setup out there. But then also what I wanted to show you is I have the accessories tab with our PID actual concentration being shown here too. And again, this accessory tab can be many different third-party devices. Doesn't have to be a mini array, but we do have the mini array connected today. And I can go ahead and see the history of it. So every 3 minutes, the sample will be recorded in here. And then this is our real-time readings right here. So you're seeing we're about 1 part per million. It is kind of windy out there, so the concentrations are kind of going high, then kind of low. So right now we have 390 parts per million acetone. The communications that we're using is through the AccuCom. The AccuCom is a 900 megahertz receiver module that just plugs in through Cat5 back around to your port on your computer. So that's how we're generating and receiving the 900 megahertz signal from the instrument. We're going to go outside in a little bit here, but before we do that, I wanted to show you, this is just a representation of some of the chemicals. These are just different chemical lists. AccuSense can be customized to whatever you need, but chemicals have to be within our minus 50 degrees C up to 100 degrees C boiling point range, the more volatile things. And that makes sense, right? If we have a spill, we have more volatility of that chemical at less than even ambient temperatures. In the North America, we have temperature ranges all over the place, but pretty much we're not going to get too much beyond 100, 140, 150. So definitely that boiling point range is really good. So we can provide you this information. Just give us a call, give us an idea of what kind of chemicals you want on board. The instrument itself can have 25 chemicals in its library, customized to whatever you want, plus 3 more libraries of 25. So we can have up to 100 chemicals on your instrument. And that would then give you a good indication of what's in the field. You can see here, I'm going to go to the second sample. Our second sample was down at 174 part per million. So our first initial one was at 390 because we did spill a little bit of acetone out there. And again, I'll show you that outside. Now, you can see it went from yellow, and then the second sample was green. It's based on concentration. When we get into yellow, we're at the acetone's permissible exposure limit. All I have to do is just gloss over it, and you can see the NIOSH time-weighted averages of 250. OSHA is 500. So we are using the NIOSH on this one, but we can customize that for you as well. And then the second one is green because we are below that mark. And each chemical that it identifies, and again, we're detecting, we are identifying and quantifying, has different marks with different concentrations for those things. So we'll come back to this in a little bit. And again, I'll go down here, look at that PID. We're getting 167. So it is a bit windy out there and gusty, so we're getting some wind. So we're gonna go outside and we're gonna go through the office here. We're walking through, and there's Ben. There's Ben's our work dog today. How you doing, Ben? And no, here's John. John Lee, Inside Sales. How you doing, John?
I'm good.
John's working on some gas detection stuff, I'm sure. So we're gonna go back outside here. Now we're not going very far away. We have a metal building here, so we're only going maybe about 100, 200 feet away. That 900 megahertz radio can reach out and go a little bit farther, probably about a mile or two. We're not really in the radio business. We don't really care, but we'll put whatever radio, cellular, any kind of communication stuff that you want. So, okay, so I'm gonna walk up on this unit here. And I do have it plugged in, but I'm gonna actually unplug it because we don't need to be, it's got its own battery supply. So we're gonna go ahead and, what you first can see is look at the quad pod. This is the quad pod that's been designed for the AccuSense. And what's kind of cool about it, it has a nice shield at the top. You can see here for solar load and for also rain shield. So you do have that. And then you can see here, you got the instrument underneath, all tucked away. And you have up here is the antenna. It goes right through the top of that shield. The stand has legs can be changed as far as their height. You can see I'm on uneven ground here. So I have this leg over here longer than the other to make it sure that the instrument is nice and stable and horizontal. How cool is that? So very, very easy. And this stand can be put up in less than 5 minutes and torn down in 5 minutes. So it's a very quick deploying type stand. Although you don't have to use the stand. Instrument is more than enough weathered, protected, just to leave it out on its own, but you can definitely use the stand. Now, you'll see here too, we have the 2 battery packs. It's 2 sections here. So when we have it all connected, we have 8 hours of battery power in the bottom section battery, and then the internal battery inside the AccuSense has got another capacity for 8 hours. So combined, like we have it here, we can go 16 hours on a charge. Also, I've been getting calls and say, hey, is there any alarms or anything on the device itself? Well, there is. You can barely see it here, but you can see the lights here, and we have different colored lights. So these are indicators of a low, medium, and high. Now, when this thing was first designed, it was designed to be left in an area and you go back and get out of the area. We didn't want to put people in harm's way. So it was a standoff type device. So we didn't put any expense or information on this part of the instrument. All the concentrations and go report back wirelessly, in this case, to the computer. And the computer does the ID identification and quantification from there. But I did want to point that out. I haven't shown that in past videos. You do get a low, medium, and high to let you know that you are in any kind of immediate danger. Over here, we have a front side. We have an instrument here. This is an inlet of our gas detector. And we have another instrument here taking a sample. And then we also have the communication from that mini ray. It's a mini ray 3000 over here. And that cable is connected to that unit, and it's that way. And so we are gonna make that connection here. Makes it simple. And here's my source. You were wondering where I get that acetone from. I'm using it in the acetone connection right here. So now that wind is blowing and it's kind of creating a little bit of an air current in here. So we're getting that little plume and a little bit of acetone every so often. So, but that is the interface. Now, again, I have it connected up to a mini ray 3000, but you could use any third-party device of your choosing, as long as we can interface with it and work with them. So that's something to consider. We have a couple of other different devices, IMS detectors, but I can see a particulate monitor as well being connected on this if you wanted that as well. Coming back around here at the top, you're going to see cotter pins. This is how the quick releases to take this whole quad pod down. Very simple and easy. And again, I told you 5 minutes to put together and 5 minutes to take down. You'll see this tray for third-party devices has little hooks that go on the handle and fit easily underneath the rain shield there. And our interface is just this electronic connection right here for this mini ray. Now, not only is it sending communication and data, it's also using the power from the AccuSense to power up the mini ray 3000. So that's kind of cool. And again, here's a release lever to separate the 2 halves, the 2 different battery halves. On the back side here, we have the 110 power supply. So if you want to go continuously up a 110, we can do that. Some customers have asked, can we put this in a permissible exposure area, like a intrinsically safe or explosion-proof area? No, we can't, because we have these open sources. But what we can do is we can pull a sample with high-speed pumps from those source areas, and in a safe zone then detect it. So we can do engineering systems to do that if you're interested. On the back side here, you'll see our connection for our Cat 5, our antenna connection, and then this is our exit valve or exit port for the instrument, so that whenever we take a sample, it does come back out through here. Come back around here, give you another little bit look of how it looks. So it's a nice, cool system. Now, how am I introducing this sample? I wanted to do it safely. We're in the beautiful town of DeMont, Indiana, and we're right next to some rail, and you can see some rail over there. But I didn't want to scare anybody. I just want to keep it really simple. I didn't want to be splashing chemical around. And it is a bit breezy. So the only way we could actually give a pretty good representation of that acetone is to basically put it in a cup. So I'm going to kind of agitate it a little bit. It's a little cold out too, so it's not really going to be one of super volatile, but it is going to maybe get up and go. So we're hopeful when we go back and take a look at the GUI, the CRID software, we are going to get some hits. But anyway, that's the system. Very, very kind of neat and kind of cool. Now let's go back, and we're going to walk our way back to the office, and we're going to take a look at the and see how that system is, what the chemicals are, concentrations are on the computer. Go back through the door here. And again, AccuSense is taking a sample every 3 minutes and then reporting that back to the PC here. So you're always getting a sample, continuous monitoring. So let's take a look. What do we got here? Okay, so you can see, here's the timestamps. Here was 157, that was our first sample, then 201, then 204. So let's go to the second sample. We already did that concentration of the first one, or let's see here. This one up here is 390. We already went over that, but I go to the next one. We are at 174. Next one, 131. Next one, 139. And again, just because the wind's blowing around, circulating and swirling around there, we're getting different concentrations. Now, another cool feature of the software is I can go over here and click on this Red 14. The Red 14 is an interconnect with the Hazmat IQ. Hazmat IQ is fully integrated in here, so I can actually, the AccuSense says what it is, and all you have to do is follow play Red 14, and you can see ends in ketone, or it is a ketone. So from there, we can just simply follow the instructions for the Hazmat IQ, and this is going to help us remediate and also give us choices of other detectors and things that we can use for acetone. The other thing we can do here is we can go to Unit ID, back to Unit ID, and I can go ahead and click on the acetone, and boom, it pops up the NIOSH Pocket Guide to Chemical Hazards. You can see here all the chemical and physical information. You got molecular weight, boiling point, freezing, flash point, UEL, all that other safety information right at your fingertips. So not only is the SEER technology, AccuSense, just an instrument and an interface with the CRID, it is giving you a lot more information how to detect and remediate a situation or a spill. Now let's go back down to that PID. Let's go back to the history, and again, you can see minute by minute by minute, you can see different concentrations, and that PID is getting updated, every 4 or 5 seconds, and then you got real-time concentrations right here. You can see we're pretty much down to 0, so it's just, again, the wind's blowing the opposite direction. And then the last tab here is our signatures. Now, signatures for AccuSense are kind of like a chromatograph on a GC. So it's not the same, but we basically are fingerprinting that, hyper-digitalizing what acetone is. And in this case, 139 part per million looks like this on the signature. Now, I can go ahead and click on a clean sample and show you what fresh air looks like. You can see the different peaks, and then I can go over here and click, and you will see the acetone peak. So basically, these represent what acetone is, and gives you a kind of a clear picture. And the instrument and the software does all the calculations on that. So all you have to do is turn it on with a button push, put the instrument in the field, turn your computer on, start the program, and then you're all good. If you have any questions on this or want more information, you can give me a call, Jim Sinesco at AFC International, 800-952-3293, or you can contact SEER directly, and I'll get you that information. Give me a shout, but you can find them on the internet, you can find them on LinkedIn, you can find them on YouTube. We're all over the place. So give us a call when you get a chance, and if you're interested, let us know. Let's see how we can make a custom unit for you.